Well, hello everyone, and welcome back to yet another video on my YouTube channel, mrbdoeselectronics. In this video, we'll be taking a look at this DIY current sensor or electricity sensor, whatever you want to call it, how I built it, how I programmed it, and what all the parts that are inside of this. So sit back, relax, and enjoy this video. And if you do like videos just like this, consider subscribing, like, share, and comment also. So let's quickly go through the functionality of this DIY current or electricity sensor. So it notifies you in audible tones as well as in a telegram bot notification about the loss of the electricity as well as when it comes back. So now at this moment it is turned on, as you can see over here, by the reading on this red voltmeter, which is an AC voltmeter by the way. So let's turn it off quickly. So I hope you are able to hear that we get 3 audible beeps from the buzzer and a female voice saying in Bengali language that the current has gone or the current is lost. You can customize that voice in any male or female or in any language. And other than that, the main thing that differentiates this from any other project out there, any other device of similar nature, is this telegram bot notification that you get. This message, inverter on detected, electricity is gone. You can customize that message to your heart's content, to whatever you want to get notified as a message. The bot's name also you can change. For me, I have done as electricity sensor, but that can be anything to your liking. So let's quickly show you a wide angle view and a live view of the message over here as soon as I turn the switch back on. So the beeps and the tones were there, as well as you can see, inverter off detected, electricity is back. As we have inverter connection, I customize that message like that. You can customize it to whatever you want, and that is how the notification works for the telegram bot, as well as the audible beeps and the voice commands in the female voice. So this is the current sensing meter. I had this box and this top. These two are not compatible, but I made work with what I had. You can buy your own PVC box or any kind of project box from online or any electric shop to encase the project, or you can use any other type of container. In the front we have a 15 amp female plug over here. This has got both the 6 ampere small socket as well as the 15 ampere 16 ampere whatever, the big one. We have got an AC voltage meter. So this works independent of anything else. It is just directly wired, as you can see, to the AC input and or the output, whatever. On the back we have another 16 ampere plug, male plug. So basically what happens is that I made this one so that you can fit it as a pass through and not take away that plug. So this you fit this one into the existing socket where you want to sense the current, the presence of it at least. Then this just passes on the current to this one without affecting anything else, and also this gets connected in parallel to the AC current, giving you the voltage present. So that is the lesser interesting part. So the more interesting part is all in here. So let's go one by one. So first up we have this ESP8266. This is a Wemos D1 Mini. I chose this because I didn't need too much pins, analog, digital, whatever, and this is small in size. I thought it would be a good thing because all of this AC and DC current all mixing up, it's not a good thing. So I went for the smallest DSP board that I got for cheap at least. Then we have got active buzzer over here, which has got a hole on the side, if you can see. So this gives you the audible beeps. And next up we have a 5-volt DC supply on the inside, which takes the AC from coming from this external power socket. And then we have a small, like a speaker. The buzzer gives you audible tones in square or sine wave, but this actually lets you give you like voice commands or voice. And we have got the DF player mini over here. This is actually not the original DF player mini. This is just a generic, as you can see, MP3 TF16P. And we have got a 4 gig card, whatever card I had laying around, with all the audible voice commands that lets you know when the current is lost or when the current is has come back at least. And last but not the least, the main component that you need for this project is this ZMPT sensor. If you can see on the inside, ZMPT 101B. I'll give all the links of the parts in the description below, check it out. So this is the main current sensing part. So what it does, it takes the AC input and then it provides a compatible 3.3 volt analog output which gets fed into this ESP8266A0 analog pin, which then processes it, and based on the loops and the conditions that are put in the command, whenever that sine wave or that loop or that analog signal of the AC current gets lost, then we get the notification in both the speaker, that is the voice command, as well as in the buzzer format, and whenever the current comes back, it again starts to read the analog signal. And this is the UPS module which supplies the 5 volt necessary to keep the ESP8266 or the DC system powered on even when the electricity or the current gets lost, and whenever the current gets back, it simultaneously powers the ESP system as well as charges the 18650 batteries, as you can see over here. Now let's quickly dive into the programming itself, which was the main tough part for me, at least, programming all this logic into it. It's a really sophisticated programming, at least coming from me. I am not an IT personnel or a programmer expert by any means. So let's get into it and I'll explain it as best as I can. So this is my final version of the programming. So let's quickly go through it. So these are all the libraries that you have to include. You people already know that better than me. Then we have got the EEPROM Wi-Fi storage. So what I have put in this option is that whenever the first time that you flash the device or the ESP with the programming, it asks or you need to hard code it with a Wi-Fi credential as well as the passwords and SSID and everything. So what it happens is that for the first time it boots up, in your Telegram bot, in the chat section, you will get an IP address thrown out by the ESP to the Telegram bot. I'll throw up a screenshot here right now. You can go into that IP and then put in the Wi-Fi credential, which it will store in the EEPROM of the ESP. And for the second boot up or the subsequent boot up, it won't require this step anymore because it has saved that Wi-Fi credential. This is only for the first boot up after flashing. Okay, so this is that part. Other than that, these are all the pin settings. This is the analog pin for the current sensor. This is the buzzer pin D5, and this is the D6 and D7 is the SD card of the DF player mini. There is the TX and the RX pin. This is the initialization of the DF player. Then we have got the detection settings over here. So I have marked all the different sections using comments. Then we have got the Telegram section. So this is the bot token over here that you will get after you have generated your Telegram bot, and then you have to put in your chat ID, that is your exact Telegram account. It has got a chat ID which is unique to that, so you need to put in that so that the bot that you have created can talk to you via your personal Telegram account. Next, we have got all the section, the EEPROM helpers and everything. Then we have got the Wi-Fi connection part, the looping part. Then we have got the config portal that we have already talked about. Then we have got the Telegram part, that is how it will contact the Telegram backend, the server, and talk to you. Then we have got the announcement section. So here you can see that I have got all the different tracks over here. This is play MP3 1, this is the first track. This is the play MP3 2, second track. So just like that, all the different tracks are laid in over here. For example, play MP3 1 signifies that inverter on detected electricity is gone, and this is the part where you can change whatever message you want to display on the Telegram chat section. This is the line, and this is the other line where you can change to give any custom message over there. And these are the two lines where the two MP3s that I have linked get linked to this programming itself. Then we have got the void setup part, this whole thing. Then we have got the play music part. So basically I have put in a short chime, a boot up sequence chime, which is not required, but it's just for the hell of it, to make it a little bit more flashy. For the first time it boots up, that is the ESP has got no power, no AC power, no battery power, no nothing. As soon as you plug it in, it will provide these kind of chimes and boot up startup sequence, which are all stored in the DF player mini over here, and for how much time there will be delay, all of these are set up over here. So this is the main looping part, and that's about it. I don't think I have gone into too much details, tried to explain it as best as I could. I hope this helps. So I think that Telegram bot and the whole combination makes this project a little bit unique, and there is nothing out there anywhere on YouTube having the similar nature of options or features. There may be many electricity or current sensor out there, many commercial options out there, or any DIY out there, but a combination of these, I think this is the first, and this is what makes this project by Mr. B a little bit unique from anything out there of similar nature. So I hope all of you really enjoyed the making of this DIY electricity or current sensor. If you do like these kind of DIY electronics videos, tech video, gadget video repair, consider subscribing to Mr. B Electronics. Tell your friends and family to subscribe too. Like, share and comment also, and I'll catch you guys in the next video. Peace.